Okay, I see people are connecting. Hello, everybody again. Good morning, good afternoon, good evening, wherever you are. Welcome to our monthly Paula Kantor seminar series. We have re-initiated meetings after Science Week. This is the second one. And as you know, I think those of you attending more frequently, you know how it goes. We have a presentation. And then followed by an intervention from our special guest, Agnes Wisumbing, who is also here joining us, who's a senior researcher at IFPRI, the International Food and Policy Research Center in Washington. And she will give a short intervention after the main presentation, after which we will have an open Q&A session where all of you can comment, ask, anything. So today we have a presentation from our colleague Moti Aleta, who's an agricultural economist based in Ethiopia, in Addis Ababa. And he will give a presentation on exploring the gendered agricultural productivity differences and the role of varietal age. So I've seen the presentation already, so I've had the sneak preview and it looks very interesting, and I'm looking forward, Moti, to hearing your presentation. Can you try and share the screen maybe?
Do you see my screen?
We only see you,
which
is also a good side, but it's not the presentation. No. If you have problems, I can also share it.
What about now? I revised a little bit.
Okay. No, we still only see you.
I already shared it. Screen one.
Now something is happening here.
Is it
okay,
coming?
There it is. Yes, it's there. It's also in presentation mode. All good. Please, Moti, go ahead. You have about 25 minutes, more or less, 30 minutes. Please. Thank you so much.
Thank you, Mike. Thank you for the introduction, and good morning, good afternoon, and good evening, everyone. Thank you for coming to this seminar. We're analyzing some data from varietal monitoring exercise we are doing in Ethiopia. And then Mike asked me to present something in relation to gender. And so we tried our best to give some essence and extract some insightful results that we can discuss this afternoon during this seminar. So I'm going to talk on exploring gender and cultural productivity difference in Ethiopia in relation to varietal age. To give some background, gender gap in agricultural productivity is, these days widely accepted, and there are some findings also from literature, that maize productivity, for instance, in Ethiopia is 44% higher for male-headed households as compared to the female-headed counterparts. And also some other study in 2015 from Ethiopia shows that there is 23% productivity difference between men and women farmers. And then the authors tried to explain this productivity difference, and 43% of the 23% difference was related to the land manager characteristics. That's completely gender and land attributes and access to resources. A study from Malawi also showed some productivity difference again from between male and female managed plots. In Malawi, interestingly, there is 8.2% endowment advantage for women managed plots, but interestingly, there is 23% structural disadvantage for women managed plot. That means it's not only the endowment that really matters, but there are other structural issues that contribute toward this return to resources that women might not have, including extension services. This is some figure again from different studies showing the productivity difference between men and women managed plots. in Nigeria, Malawi, Ethiopia, Niger, Uganda, and Tanzania. To give some additional insight, on the genetic innovation and crop productivity, breeding and genetic innovations are useful in adapting to changing climates and socio-economic challenges we face in our daily exercise. And also, recently released varieties they are bred usually to challenge recently occurred production challenges, whether that's a pest or disease, or any identified consumption and market-related demands. So adopting recently released varieties is really helpful to address these challenges and then make smallholders benefiting from it. But when you're looking at the adoption level, it's usually slow and low. That really limits, both household and national level potential income, food and nutrition security benefit that would have been attained from these innovations in genetic improvement. Again, once these improved varieties are adopted, there is a tendency that farmers also keep growing the same variety for many years. As varietal replacement is a slow process, mainly because of the supply and demand side challenges. There are many aspects that we can discuss here on the supply and demand side, but I picked two things here. From the supply side, seed companies are less interested to go for new release because maybe they have a popular variety in the market that might have a good share. So they would like to keep that one and benefit from that marketing. From the demand side, again, there are many aspects that influence the varietal turnover or replacement, but risk could be one of the cases, especially as our smallholder farmers are risk averse, and then any shock that's affecting their income and consumption is really challenging them to try new products that they are not familiar with. Gender and access to improved varieties. Technology uptake is really different by gender because of demographic and other economic and social factors. This has been studied a lot starting from 2000, basically by Dawes and Morris, and there are many studies that are witnessing that. Including our recent studies, there is also, an indication that male-headed households are more networked and have more access to improved technologies, and they are benefiting more from the remunerative opportunity that improved technologies are generating. And social and economic dynamics are getting improved over time. And it's also important to check, if this kind of progress are really changing some of the dynamics in technology adoption. With that background, the 2 days presentation tries to address some three basic questions. First one is trying to assess whether the age of variety that farmers use is explained by household and farm characteristics, and also explore whether crop productivity is associated with varietal age, and then finally see if yield enhancing complementary inputs in crop production are related to the age of varieties grown, and whether this is varying by gender of the household head. In varietal turnover assessment, there is a key requirement that is, accurate varietal information from farmers' field. Usually we are relying on farmers' report for the variety that they're growing, but that might not be really accurate enough. So here there is an advantage that we have from the data that we are analyzing in this presentation. DNA fingerprinting of field samples and matching that with close to complete genetic reference library, that is the genetic material from the breeders, for a maximum identification of field sample that we collected from the farmers. And this requires, again, a continuous update of the genetic reference library to be incorporated or incorporating recently released varieties. Otherwise, we are missing more recently released varieties if we are not keeping continuous update of the library. The data that I'm going to present is collected under image and DNA fingerprinting project in Ethiopia, and we also associated some kind of survey, a small survey related to that. So we collected grain sample from nationally representative and randomly assigned crop specific plots at the enumeration area. The Central Statistical Agency, now called the Ethiopian Statistical Service, is having a crop cut from 4 by 4 meter for yield estimation. So we are using that as an advantage, and then getting 200 to 150 gram of grain from the crop cut, and then sending that to the local biotech for DNA extraction, and then shipping that to Australia to diversity arrays technology for sequencing relation to the genetic reference library that we have built based on breeders' samples. And these are the partners engaged in this data collection and the whole project financed by Gates Foundation, and CIMMYT is part of it. And the Gates Foundation is resourcing, commissioning resources, and then DART, Ethiopian Statistical Service, and Ethiopian Institute of Agricultural Research are part of the whole work. So this work is in partner with multiple organizations. The data looks as presented in this slide. Two phases. The green one is the earlier DNA fingerprinting project, and the light blue one is the current image project. But in all cases, we have been collecting field samples, extracting DNA, and then referencing this DNA with the genetic reference library and identifying varieties. So in this analysis, we have like 2 rounds of maize from 2014 to 2017, and 3 rounds of wheat, 2014, 2016, and 2018, and for teff and bean from 2021. During the earlier days, we have good level of varietal identification by DNA fingerprinting, close to 1-to-1, almost 100% identification. But due to methodological change, we faced a big challenge in the recent project where we managed to identify only 27% of the teff sample and 11% of the haricot bean sample that we have collected from the field. So varietal turnover assessment is basically done on identified varieties using DNA fingerprinting. So we are focusing on identified ones, and we are not doing any varietal turnover analysis on samples that the DNA is not identifying. To give you some highlight on the varietal release in the country, a long history of developing and continuously releasing crop varieties, but even more number of varieties, during recent years in the 2000s, 2010s, there are a number of teff, haricot bean, maize, and wheat varieties that have been released. So in terms of number of varieties available from recent release, Ethiopia is really doing well. But looking into the varietal age, especially from the seed supply side, this one is seed supply quantity weighted varietal age based on data we got from the Ministry of Agriculture from 2019 to 2023. It's rather good, but if you look at teff, for instance, the varietal age for any seed produced for dissemination is more than 20 years old, from 2019 up to 2023, a bit lower for 2023. And then OPV, maize, and also haricot bean, 3 of them are a bit older They are considering old varieties in the seed production system. And wheat is benefiting from the rust epidemic, so they are focusing on more recently released resistant varieties. Overall, this is what looks like. More older varieties in the seed production system for self-pollinated crops, except wheat, but for hybrid maize is getting closer to 10 years on average. So that's a good indication, which is declining as well. Considering the 2023 average here and getting back to the varieties released over years, in wheat, we are really good, closer to the recent release varieties. For hybrid maize as well, but for teff and haricot bean, we are still lagging behind. The bars are showing where the average shows for 2023. Overall, the data from FAO stats is showing that there is an increasing trend in crop yield in Ethiopia. This is for haricot bean, maize, and wheat. Overall, there is an increasing trend, but at the same time, we see, for instance, in the wheat graph on the right-hand side, there is still, a potential yield gap between what is actually considered as a national average and the maximum yield of released varieties as they were tested on farmers' field. For the wheat, the green arrow is showing the divergence between the 2022-23 average yield data and the 2013 varietal released yield data. If the recently, adopted wheat varieties from 2023, still, there is high opportunity to maximize the genetic potential that we have from the varieties through crop management. This is just to give you a comparison between varietal age by crop type and year, using the seed supply quantity weighted average and from the DNA fingerprinting data. For wheat, in both cases is declining, but the seed supply is really good enough compared to the number of years. For instance, for wheat, 2025, the average was 21 years. 2017, it was 13. And then 2019 data shows 12 years. This is from farmers' field, but the seed supply is more recent in terms of varietal age. Maize, there is not much change between 2015 and 2017, but this is an aggregate of OPV and hybrid. But if you split the OPV and hybrid, we are expecting a declining for hybrid more tremendously. So this one is more aggregate and is not reflecting the actual hybrid OPV variation. The note over there is, for haricot bean varieties in seed supply were more recent compared to what was observed in the field. In the field, the average is showing 28 years, but in the seed supply system, the average is 14 years. So maybe still farmers are growing much older varieties compared to what is available in the seed supply system. Using all data that I have showed, we also did some kind of regression to see what is really explaining the variation in varietal age considered as years since released. There are a number of variables that are explaining, but here I picked like 3. First is, the plot size. Plots that are larger, especially for wheat and maize, they are attracting more recently released varieties, and also distance from commercial seed sources. That's again is growing recently released varieties. So who are residing far away are depending on older varieties. That's expected. And also those who are getting seed from formal sources, they are growing more recently released varieties. The objective of running this regression was not really for these confounding factors, but we tried to see if the gender of household head really affects the varietal age. But unfortunately, whether it is male or female is not really significant in terms of varietal age that farmers are growing. That means male and female farmers are growing a wide range of varieties with different varietal age. So the difference between the two is not really significant enough at 10% level. But we tried to get a bit deeper into the data and then tried to see if we can see some interesting results by considering crop-specific analysis and only considering varietal age and the gender of household head. This is for teff. For teff, there is a slight yield difference between women-headed and male-headed householders, and also in terms of varietal age, again, women-headed householders are growing a bit older varieties compared to their male counterfactors. The yield is like 13% lower than the average yield for male-headed householders. And then putting 10 years as a cutoff point to say teff variety is old. Again, teff yield is higher for varieties released during the last 10 years. But this has to be taken with caution because this is just only considering the raw data that we have from the crop cut without considering the management difference that farmers are putting. For haricot bean, more or less the same, but not much yield difference between women-headed and male-headed householders, even though there is a declining trend in yield in relation to varietal age. As the age gets higher, there is lower yield farmers are getting from the field, and varietal age is a bit higher. No, it's not actually a bit, but higher for male-headed householders compared to women-headed householders. Women-headed householders are growing more recently released haricot bean varieties, which is contrasting to the teff analysis results. And overall, there is a declining trend in varietal age and yield relation, but there is no average yield difference between varieties released before and after the last 20 years, considering 2021 as a reference. We put 20 years cutoff point by just looking at the graph that you see. There is a distribution gap between before 20 and after 20 years. And interestingly, male-headed householders are growing a variety called Mexican 142, which was released 1973. It's more than 45 years old now, which is still popular in the production system. We tried also to look at the complementary input that farmers are applying to genetic innovations, if that is also associated with the varietal age farmers are growing. In this case, we considered maize, and in most cases, farmers are putting chemical fertilizer to maize, then putting 3 cutoff pointers at 5 years since released, at 10 years since released, and 15 years since released, to consider a given variety is old and new. Interestingly, there is a clear fertilizer application rate difference between old and recently released varieties. Whatever cutoff point we are putting to say a given variety is old or recent. The first table is more generic, but we tried to split between OPV and hybrid very clearly. There is not much difference in terms of fertilizer application in OPVs, but for hybrid, it's really clear, when we are having 5 years as a cutoff point and 10 years as a cutoff point, showing that, farmers put more chemical fertilizer to varieties which are more recently released to make the genetic advantage that recently released varieties have in terms of yield potential. Then we went one step further and tried to see if these complementary inputs by varietal age differs between male and female head householders, regardless of gender. Again, there is clear difference that farmers are adding more to recently released varieties, both for male-headed and female-headed householders. But generally, looking at the newly released varieties for male and female, newly released varieties grown by male are on average receiving slightly higher chemical fertilizer rate compared to their counterparts, female-headed householders. So from this preliminary analysis, there are some few conclusions that we came up with. Seed production system needs to ensure, the supply of more recently released varieties. Still, the varietal age, even considering the seed supply side, is still high. Whether recently released varieties generate better yield or whether men and women farmers treat plots received more recently released varieties with good management, it's important to encourage the uptake of recently released varieties to help boost their crop productivity and production. Again, regardless of the varietal age, we say from the result that women-headed householders should be supported in boosting their investment in crop management technologies and practices for better crop productivity. I better, stop over here and then thank you for your attention. Would like to get some feedback from you. Thank you.
Thank you very much, Moti, for your presentation. I would like to hand over now to Agnes for her intervention. Agnes, please,
Sure.
The floor is yours.
Okay, thank you so much for having me, and thank you, Moti, for your very interesting presentation. I must say that since I'm not an agronomist, one of the things I really like about the CIMMYT series is that you use a lot of agronomic and biophysical data, and it's always a chance for me to learn something new. So, I sometimes like to put myself in the shoes of the presenter. Like if I were a presenter and I had this data, how would I organize it if I'm presenting to an audience that is primarily interested in gender research? I would probably rearrange your presentation a little bit. Because one of the very interesting things that you showed when you were doing only like a 2x2 analysis between yields and gender is that you see this gender productivity gap, so that's how you introduce it in your introduction of a gender productivity gap. But when you go to presenting the results by adoption of use of older versus newer varieties only by looking at gender, you see a difference, right? You see a difference in theft with women growing older varieties. You don't see a significant yield difference in beans. And you see it in maize. However, when you control for other confounders like land size, distance to homesteads, these gender differences disappear, right? So looking at those coefficients, they disappear. So the way I would interpret that is that if I would start first by presenting the 2x2 and say, okay, there's a gender difference. But once I control for the other things, the gender difference disappears. So what does that tell us? So it tells us that a lot of the differences are probably because of other barriers like land holding size, distance, access to formal sources of credits. Now, these themselves may be related to gender in the sense that women-headed households are probably less likely to have larger plots. They're less likely to have access to formal sources to credit, but it's not gender per se, but the difference in access to the, to the other factors that, that constrain adoption. So, so I guess for me, the question would be, it would be interesting to see whether input application also varies by varietal age for other crops, and what factors actually contribute to the yield gap. Is, say, for example, for maize, where you do demonstrate higher fertilizer application for newer varieties. Is it difference in the adoption of newer varieties, or is it differences in the fertilizer application to the newer varieties that's driving the gender difference in yields for men and women farmers? So you could actually do a decomposition similar to what the folks in the World Bank do for, for that analysis, whether it's coming from the varietal adoption or whether it's coming from the fertilizer application. But my last comment is that in your data, are you looking at men and women plot managers, or are you looking at men and women, male and female headed households? Because the lower the level of disaggregation, like if you're disaggregating at the plot level, you're likely to find more differences than you are at the household head level. That said, I mean, I have worked in Ethiopia before. There are clear differences between male and female headed households. So in this context, this type of analysis may be justifiable, but just to sort of push you towards a little bit in the frontier of, gender work, that if you can do analysis at a more disaggregated level, that would be great. That's all, but it's a very interesting presentation, and I think you have a lot of potential to take this forward. Thank you.
Thank you, Agnes. I really appreciate the comment that you put forward, and especially the rearranging that presenting this. We'll consider that one even when we are writing the paper. So the other point that you raised, we have to go forward with it as well. The looking into the interaction effect is what it looks like, and what is the implication of input application, whether it is the input or the adoption of the genetic innovations that contribute to the yield variation as well. The data was not really collected with the intention of the analysis that we are doing at the moment, but we are trying our best, to come up with some interesting results from the analysis that we are doing. Otherwise, given with all the detail that we have, and we'll get something interesting out of that. And I really appreciate the comment that you put at last, looking into plot managers and versus the male and female headed householders. This was collected at the plot level. There is some information that we collected who is managing the plot as well in this small survey that we ran, and then we try to consider that and see if plot management also matters in this aspect. Otherwise, thank you very much, Agnes, for your feedback and reflections.
Thank you, Moti. Thank you, Agnes. There are some more questions in the chat, so I would just
hardly see them. Let me stop sharing.
Yeah, maybe you can stop share. Yeah, I will ask Dasha. Could you maybe just unmute yourself if you can? If you can't, for whatever reason, we can read it out. But maybe it's better if you post it directly to. Oh yeah, here you are.
But
yeah, welcome.
I don't want to. Hi, thank you, guys. I don't want to hog the session, so maybe I just ask. When you're saying female-headed households, Moti, is it like de facto female-headed households who are, like women whose husbands are away, and also women who do not have a husband? So I was thinking, I think someone also mentioned this, maybe Michael, in an earlier session, like, oh, a female-headed household means that there is one less adult, working adult. So maybe we should be thinking about yield in terms of yield per adult equivalent, so that we can compare objectively.
Thank you, Dasha. I couldn't get the last point, but the first one is straightforward. Is female head households in here are the de facto one, whether they are divorced or the male head is not around. So the female family member is the one who is doing the actual farm operations. But the last one is okay. So we should be looking at the yield per adult equivalent, since most female head household have one less working male. Okay.
Let me
Yeah.
quickly say something about that. You could also
Mhm.
control for household composition in your regressions.
Mhm.
You usually use adult equivalents in nutrition or food consumption. And I don't know how you would compute whether adult equivalents would be helpful in a production regression, for example. But I think that some control for household demographic composition, you might get more mileage out of that. Just add that in
Yeah,
your regressions.
that's possible. We have the household enumeration with all the age and other related data. That would be possible to do that, and then see, especially, if there are operations that need male labor, and if the labor market is failing, for sure, there is some kind of productivity difference in terms of time of planting, time of harvesting and threshing and all these things. Yeah. Thank you.
Thank you,
Mike, you gonna
everybody.
read, or shall I follow the
No,
order
let's
that I said it?
open Dorcus, please go
Yep.
ahead, open your mic. Let's have this a bit more interactive.
Yeah, thank
If you
you
don't
very
mind.
much for the nice presentation and those great insights. Coming from crop improvement, I think you have studied how the uptake of new varieties in male and women-led households. But I was wondering, of those new varieties, are there any differences between those varieties that are taken by the female households that are different from those that are taken up by the male households?
Okay. That's an interesting, insightful question, Dorcas. Yeah, I mean, the way we analyze it now is just considering the varietal age with some kind of cutoff point as new and old, or new and recently, old and recently released varieties. But we didn't really put much effort in looking at, what are these specific varieties that are adopted by male and female specific groups, and whether there is any genetic potential difference even, in this specific group of varieties, if there is a difference between the two group of varieties adopted by male and female headed households. That's a good point, and we can look at it and then see if the yield difference is even, from the genetic potential that might be existing in these varieties adopted by the different groups. Thank you.
Thank you.
Thank you, Moti. If you have additional questions, anyone on the call, you can also just raise your hand. You don't need to type it in the chat, or any way you prefer. Please, there's a hand up. Is this Adefris?
Adefris, yeah.
Please, Adefris, go ahead. Adefris?
Okay.
Adefris, you are muted.
Yeah,
Thank you, Mike. Thank you very much, Mike, and also thank you, Moti. I have few issues, but let me put first actually how fertilizer rate is associated with the varietal age actually. For me, is there a compounding effect between the trend in fertilizer? Because fertilizer consumption is increasing from time to time, and I know that all varieties are released for the same fertilizer rate, like for maize, teff, and the like, and there is no difference between varieties' response for fertilizer. And for me, do you think there's a confounding effect of the age within the trend of high trend of fertilizer utilization in the country? Well, basically, I would like to appreciate also the way you scrap the data of the fingerprinting toward this showing some gender response or effect. This is one of the issue I have, and probably if Mike allows me, I will ask other questions later.
Yep. Thank you, Adolphus. I mean, I'm not sure, I have to look into some other FAO data if there is an increment in the rate of fertilizer application looking into crop specific as well. But, in this analysis, we consider specific year fertilizer rate application, whether if it is for maize, is 2014 and 2017. And we accounted for the year in the analysis, especially in the regression. But in the figure that I have shown, the year difference is only like 3 years, 2014 and 2017. But, the relationship that I'm expecting between fertilizer rate and more recently released varieties is more on the packaging, especially if they are using more recently released varieties, and if the extension system is advising to use, the right recommendation with this more recently released varieties to benefit from the genetic potential of recently released varieties, that might be influencing the farmers to go for it. And interestingly, it's both for male and female headed households. Overall, what we see is more application rate when they see that these are more recently released maize varieties. Otherwise, this is not something we are regressing fertilizer application rate with varietal age.
Okay, thank you.
Yeah. Adifris, I will allow you, of course, how wouldn't I? But if I can come in first, because I had also a question to Moti, and it relates to the comment that you had just made regarding this.
If you detect me, actually, I can go and ask him in person, no problem. Because okay.
No, there's still some time.
Anyway,
can I ask my question first, Adifris? Then I'll give the floor back to you. Okay. Because it's related, my question, to this one. I wanted to ask, because it's also related to your question, because there's other work where they find the same. I would have to check it, but it's not, I wasn't surprised when you saw that. There's something, if farmers think they are using a more recently or a better improved variety, they manage the input use intensity is higher. So there are other studies that show the same pattern. And also I found it interesting that you have, it's quite large, right? These differences that you found. And since it's DNA fingerprinting data, my question would be, you probably, or do you account for farmer misclassification, misidentification of their varieties? Because if you don't, then the true effect may even be larger, because in that data, you may have farmers that cultivate a hybrid and they don't even know about it. So they don't give it the proper treatment. You know what I mean? Yep. Yeah, maybe you could just say something about this one. Thanks.
No, thank you. Thank you, Mike, for raising a very interesting point. And interestingly, yesterday in the late afternoon, we have been discussing this with Bisrat to give another dimension of the data analysis, looking into this misreporting of the varieties and misperception of the variety knowledge, and then how that is really influencing the level of complementary input that farmers are using. So this false positive, false negative knowledge of varieties, as we are identifying using DNA fingerprinting, and if there is that some associated penalty that farmers are having because of excess utilization of fertilizer when the variety is actually old, or if they can still even increase the level of yield benefit if they think that they're growing old but actually growing recently released variety. So this kind of analysis, there are some earlier works by colleagues in IITA and also IFPRI on misperception, misreporting, and how that influences the input application and then actual benefit that farmers are getting analysis. I know one paper from Tasfa Michael Wilson, IIT on cassava. So this is what we have talked yesterday, and then we'll do our best to give some kind of analysis on that side. Thank you, Mike, for raising that.
Thanks, Moti. I see, Bisrat, you have your hands up, probably related to the same discussion.
Oh, Bisrat, you are in the room.
Yes. Thank you, Moti, but it's not directly related to that.
Okay.
Yeah, it was very interesting, Moti, and definitely when it's just a comment, especially when you push the study into the next steps. You mentioned there was this methodological change in terms of the DNA identification, yeah?
Yep.
But I kind of understood what was changed, but when you have both the data in the same regression or in the same paper, then there might be some explanation needed, yeah? What is the misidentification rate? Because you have for maize in 2016, 99%, and
Yeah.
then you have 11% identification for
Yeah.
beans. So one of them has misclassified or misidentified, and based on the methodology that was applied, yeah? So maybe a matrix of showing what would have happened for the beans if we use the previous methodology, how many of them we are going to identify, or what would be the identification rate using the new methodology for maize, yeah? So does it drop from 99% to I don't know, 50%, something in terms of kind of introducing this measurement error into the data before it goes to the regression.
Thank you, Bisrat. I mean, in terms of the analysis that we have conducted now, I mean, that doesn't really affect much because we are relying on already identified subsamples. But the subsample is really small for teff and haricot bean. Maybe that subsample is really too low, and it might not be really representative compared to the field sample that we have. So there might be some kind of bias, but we are relying on identified varieties. And at the same time, to your question, the team is reanalyzing the historical DNA fingerprinting project data using this cluster pipeline analysis, and then see, with this new methodology, how much sample we are going to lose.
Okay.
Because this is clustering varieties into specific groups and then mapping a field sample into this cluster. Sometimes, some varieties might not be really matching to this cluster, and then they stand as an entity by themselves. So, yeah, I mean, this is completely a different approach that we followed in the two projects, but we are getting there, and then, for sure, we'll have this comparison by the same analytical approach that they followed in identification. Thank you, Bisrat.
Perfect. Thank you, Moti.
Thank you. Adefris, do you want to come back with your follow-up question?
Okay. If there is no one, not really, I can. Yeah, my issue is also on the introduction part or somewhere there. Moti showed us actually the yield gap between for wheat specifically, and me actually that issue is very controversial because Ethiopia is not divided into belts like wheat belts or maize belts or haricot bean belts. So whatever statistics or the potential of the varieties that have been displayed in the varietal registry book is for me actually based on the areas where the best yield is collected from specific crop. So the gap actually has to be or need to be qualified in a way that if it is grown in the same agroecology, actually, where it has been tested and showed the that amount of yield. Otherwise, it will be, especially for people, policymakers and the like, it may be a misconception. Like, for example, Moti, thank you very much for bringing this here. It shows 6 ton actually per hectare.
Mm-hmm. Yep.
Probably it could be in RC Highlands or in Noari or Minjar.
Okay.
The tested the sites testing sites. But if you are expecting the same amount of yield after planting it everywhere in the country, it may be. I think there is no way actually to realize that. Even in Asasa, okay, it's more than that. Definitely in Gojam, West Gojam. So probably this interpretation may be, I think, not good. No, and I'm not comfortable always even in maize, ape, and all, because we are reporting actually. We test them in the best areas, or not always the best, but in our research centers and the on farms that are suitable for that crop. So maybe a little bit confusing and misinformation, I think.
No, thank you, Adafris, for raising this. Here, I tried just to be modest, in using the maximum yield of released varieties on farmers' field, comparing that with the average national yield from FAO stat, and then try to see the genetic potential we have and where we are now, and how much of this genetic potential is yet to be realized by different crop management practices. Whether this is going to be fully realized or not, that's a separate analytical issue. But at least there is still a potential gap, and even in a way this is modest, up to 50%, but in some analysis this could be up to 75-80% yield gap potential compared to the no water stress maximum attainable yield in the country. So yeah, this is to show where the genetic potential is and where the national average productivity is, and whether there is still a potential to push the national yield using the existing genetic innovations we have in the seed production system. Otherwise, I share your view that this needs to be disaggregated by location and referring to the areas where the varieties were tested, and looking again, the local average yield, and then see how much we can still attain with the existing genetic potential for that specific location. Thank you.
Okay.
Thank you very much. Yeah, it's always dangerous, Moti, if we show these type of graphs with breeders in the room.
No, it's
No, but
good.
it's
It's
very
good.
good.
It's good. No,
Of
we
course, no.
rely on the explanation that they make.
No, I'm
to be
joking.
there.
It's helpful, actually. Thanks, Adifris, for
Yeah.
raising this. It's good.
Hey.
I think that's also what Agnes said in the beginning, right? This is, she's not an agronomist, but she enjoys hearing these things, or being exposed to some sort of examples from the more agronomy side. Most of us here, or many of us, are not agronomists either, right? So even we can learn and benefit from some inputs of our breeding colleagues because they bring in a different angle or a different interpretation, or they may raise our, we have to be cautious here and you have to be cautious there. So I think that's quite good. So the seminar is fulfilling its purpose, bringing together different disciplines, different colleagues who maybe don't always talk about their work so frequently on a day-to-day basis, which is very good. Are there any further comments?
Yeah,
remarks?
I wanted to raise one interesting issue.
Please.
For me, as a breeder, it is very interesting to learn that the haricot bean yield is decreasing. The same variety yield is decreasing along years, and it to be amplified. This issue has to be amplified, actually. Probably, well, I don't know whether Moti has the interest actually, why it is reducing, and otherwise this has to be really a very good background for explaining the value of improved varieties, varietal turnover. Even the same variety is decreasing, okay, it degenerates genetically, or there could be a disease, or there like so many things. But really, this is a good foundation actually to speak that seed has to be recycled, not variety only. Seed has to be recycled, and also variety need to be recycled, even if there is the same variety we are using actually. Okay, they used DNA fingerprinting, but for me, a little bit expanded, and it has to be a policy advice or communication. Thank you.
Thank you, Adafris, for the remark. Yeah, haricot bean is interesting. You know, when I looked into the data, that farmers, a lot of male-headed households, they are growing Mexican 142, 48 years old variety. And I'm not sure if this variety is in the seed production system. They are recycling their own seed for all this long. So yeah, like as you said, varietal replacement. I mean, there must be a seed replacement as well. At some time, farmers have to buy a fresh seed, as seed might be deteriorating in terms of vigorness if they are recycling for longer years. Yeah, so that's a good point. Maybe we can flag or flash that to haricot bean breeders and anyone, public or private, who is multiplying seeds of haricot bean in the country. Thank you.
Thank you. Thanks, Adefris. Thank you, Moti. Any final thoughts, questions, comments?
Maybe
I don't see.
yeah, thank you for the nice presentation. Maybe out of curiosity, I wanted to know how is the seed distribution network in the areas of your study, because in some cases, like the just last point you made is a question to do with the seed distribution. To say if the companies, mostly those that are involved in the seed distribution, they only look at the places where they make a lot of returns in terms of sales. So how is the seed network, how is the distribution network in those areas? And are there maybe local people that are involved in stocking the seed, or maybe women agro dealers in such sites? Thank you.
Then thank you, Gekom. Gekem, if I pronounce it, your name.
Jekem, yes.
Jekem, okay.
Yes.
Yeah. So, the seed system in Ethiopia is both public and private, specifically for maize, but the rest are more public dominated. And so the public is serving, both potential areas and also other marginal areas. But the private sector, they are more dominating in high potential areas where they can make good money from the seed production system. So that point is really important. But that kind of variation between private and public is more dominant